Hello and welcome to another MyEngineering how-to video. For today's video, we're going to be doing another repair project on a plastic piece. So you may remember, if you go back in our video library, you can watch it. We had a little roof piece from a dollhouse that had broken off here. And what we ended up doing is we scanned it and we cut it in half with a mirror plane and then just mirrored the good half to the bad half, 3D printed it, and we have a brand new roof piece. Happy kids. In this case, we're going to do it a little bit different. So this is a piece from a refrigerator that is a model that is not built anymore. And so the little tab on the front of it broke off. This is, I guess the drawer would slide in and out of here. So we can either try and get a very expensive piece made for an obsolete unit or an off-brand one that you can maybe get off of a off-brand type of website, or we can take this one and we can repair the piece by digitally putting it back on and then 3D printing replica. And so that is the process that we're going to show today. So I'm going to skip the scanning portion. I know I like to show a lot of scanning. If you watch any of our videos in the library, you'll see a lot of scans done with the SimScan 42 from Scantech. It's my favorite little scanner to use for little projects like this. Incredibly fast, incredibly accurate, and incredibly good models to work with. So I already did the scanning portion. I'll show you those two scans in a moment here in Quicksurface, where we're going to reconstruct the piece. But basically, you can see I used the nice little 3mm targets. So there's 4 there, 1 on the back side, and then on the little piece here, I got 2 and 2, so that I can scan both sides and merge them perfectly, rather than using a laser point splice where sometimes you can have some inaccuracies. So moving forward, let's get into Quicksurface. So I've imported the two scanned pieces into Quicksurface 2025, and as you can kind of see, they're just not really aligned to any kind of a coordinate system or where they're supposed to be in space, because you have the little tab floating down here and it's supposed to be up here. The first thing I'm going to want to do is to try to differentiate the two pieces. Obviously, if they're the same color and they kind of blend in, it's a little bit difficult. So we're going to just change the color of the broken tab here to, let's say, a nice dark green. Now it just shows up a little bit better. So the next step we're going to do is an alignment. So we're going to align just by interactive initially. We're going to drag this one out kind of a little bit in the same area where it's supposed to be, so that we can do an endpoint alignment. Just a little bit easier when they're not overlapping. So it's sitting out there. Now we can do an endpoint alignment. And so what that means is we can pick multiple pieces or multiple points that are the same location, just to do a bit of a better alignment. So let's say we want to pick the top corner here is going to match the top corner here. We can do this one here to about here. We could do some of these pieces here. When you're doing endpoints at any time, it is nice to try to avoid making all the little points in a linear pattern. Obviously, it's going to be difficult to do when your piece is so thin. What you can sometimes trigger is you don't have any rotational control along the one axis, along where all the points are lined up. I think we'll do as best as we can here. So if we kind of pick some of these points out here, there is a little bit of variation, so not all lined up in one center axis, but we'll see how it actually lines up here. So we'll hit our preview, and you can see it's close, but it's not great. We're just gonna go with it anyway. And the last thing that we can do is going to be a global alignment. So we select our global fine align button here, and you can set the tolerance zone for how far it's going to search for common locations. I'm going to set that about 1mm because it is a little bit off here. It's not that bad, but we'll see how this actually looks. And you can see now the top plane of this piece is pretty close to being in line with the top plane of the broken tab. And overall, it actually looks like it fits pretty darn good. So we're going to call that alignment good now. And what we can actually do is we can select our two pieces here. So we'll shift and select both of them. Do right click, we can merge the two pieces so they become one mesh file. So now that we've taken the two separate pieces and aligned them nicely and then joined them into one mesh file, if you will now, we still have this unsightly little tear, and you know if you send that to a 3D printer, it's going to pretty well generate a weak point where it's going to try to break again. So we're going to need to repair this little tear in our mesh before we're quite done here. So what we're going to do is we're going to go to our Scan Data tab, and the tool that I'm going to use today is the Repolygonize tool. What you could do is you could set the point resolution that you want to use, and that's going to make some nice little adjustments here. I'm going to try 0.8 of a millimeter. You'll see in a moment here. It kind of gets rid of the tear. Certainly along the edges it's kind of repaired, but you're left with now kind of an unsightly little new tear in the center. So we're going to go to our Edit tool, use our paintbrush, going to paint the area that we're interested in. Just get a little bit more on the top. And you can defeature that. And what that's going to do is going to take the surrounding data and just kind of pull that all in so you get a nice flat little plane. That's how we would repair that. So it's a very quick little repair. There's probably going to be a little bit on the bottom. Yes, there is. And it'll be the same little process here. So you can just kind of highlight the area that you want, defeature. And it doesn't have to be perfect. We have a little bit of, I guess, wiggle room on this particular part. There's a hole I kind of left on the side there, so I have to make sure I kind of select it all. There we go. So if we have a little bit of excess material showing in the mesh here, I'm okay with that. We actually don't need this to be a really tight geometry mesh for this type of application. So I'm going to keep it pretty quick, but basically now what we have done, just to kind of quickly review, is we have the two different pieces that we scanned. We brought them both in to Quicksurface 2025. We aligned them, so we did just an interactive alignment, then we did endpoint alignment to bring them as close as we can, and then a fine global alignment in order to correct it, if you will, and so that they actually sit on the nice little plane. And then we just got rid of that little tear in the middle where the crack initially was. And so this is essentially now a mesh file that's ready to go over to our 3D printing software suite, and we can print our replacement. In this case, it is a bracket for a fridge, the deli drawer, or the produce drawer, whichever one it is, and we are good to go. Thank you guys for watching this quick how-to video. If there's any other workflows that you would like to see or questions that you have regarding 3D scanning or the softwares that kind of go with them, always reach out to us. You can look us up, myeng.ca, or you can email us direct, support@myeng.ca. And if you have any questions, throw them in the comment section below. Don't forget to like and subscribe, and we'll see you in the next video.